Good afternoon, Science 20s. Today I'm just going to take a quick little lesson on how to help you with the earthquake lab that you have in your geology workbooks. First things first, before we jump into that, I wanted to direct you to Science 20. Hopefully we're checking out our D12 homepage, and under content, I've made sure the notes are kind of complete, and hopefully we're going through them and going and reviewing all of our notes that we need to help study. So we see we have our notes organized. I've hid the student notes that are just blanked, but what you'll see is chapter 2 notes there. So we went through the tropical Alberta. We should be able to see all of our notes there. And then on to chapter 3, we should also see periods of glaciation and changing climate. Hopefully you can go through there and study the different glaciations and going through climate change to help fill out your notes in your workbook. Now, jumping to our workbook, hopefully you've done the earthquake and seismology parts. Hopefully you've gone through the tropical Alberta notes and are getting ready for our chapter 2 quiz on Friday. What you'll have to go through is a lot of these details just so we're familiar with the terminology and understanding how P waves travel and how S waves travel. When we get to our earthquake lab, here we go. It is much easier to do it by hand with a paper copy that you all should have than to actually do it digitally, but I will try my best to help explain kind of one example, and then you just have to repeat it with the other cities in Japan. So what you see here is Japan is a hotbed for seismology because, well, there's so many plates popping up and it's so active because there's plate tectonics coming together all over the place around Japan. And that's what you see in this map. You see this plate coming in, the Philippine Sea plate, the Pacific plate, and the Eurasian plate coming in, creating lots and lots of borders between these plates, causing lots and lots of earthquakes and volcanoes. So we have some data that we've pulled up, and we're going to actually look at how to use a nomometer and how to read and make earthquake scales or magnitudes or how powerful a earthquake is. We're going to learn how to do that, and we're also going to draw on a map and try to predict where the epicenter of an earthquake actually is. So first things first, as we go through some of our data, we're going to see down here, I've added an extra column, so make sure to do that as well. But first things first is we're going to figure out the magnitude, okay? We have to use these two images below to help figure out the magnitude. So what we actually need is the distance in kilometers and the amplitude. The amplitude is what actually gets registered and measured. The distance is, well, based off of this one, the distance between the P and S wave gives us how far away it actually had to travel. We've already done this. I just included this to help kind of explain it if we needed to. So we don't really need to look at our P and S wave interval because I've already figured out and calculated the distances for you. What we do need to do is take two numbers, this 0.3 and this 607. We're going to take these two numbers and put them on our scale over here. It's easiest if you actually take a ruler and just line them up, but for me, I'm going to try to go here. And what you see is it goes 0.1, 0.2, 0.5, 1, 2. It's not a steady linear step up, it's logarithmic. So you need to make sure to read carefully and place your spots carefully. So I have my first one spotted on 0.3, and then I need to go to 607. So just above the 600 mark, right about there. Like I said, easier on paper because I don't have a giant bulb on the end and kind of guessing. But right here, wherever that line crosses, that's my magnitude. So I would say right here, my magnitude is 4.5. So it's crossing. Here's the 4 line, Here's halfway, 5 is up here, so we are at 4.5 for a magnitude, and I can fill that in. Once we've figured all of these out, I also want you to figure out the radius distance to map scale. Now, this is harder because if we go down to my map, I did not give you a scale, and I didn't give you any of the cities. So you need to place the cities, and you need to figure out the map scale. The map scale, I already did for you. I figured it out, and I went to Google Earth, and I jumped up here, and I found out here's Nagata, here's Yokohama. I figured out how much real distance is between them, and then I figured out, based off of my map size, how much distance it is on my map. Don't need to worry about this because I did it for you. So what we have is for how much real distance, and I like to draw on here, I have my real distance right here of 280 kilometers about. What I measured on my map was 2.5 centimeters. So what I measure now from my information, 607 kilometers. How much map distance do I actually have? And so hopefully we know go across to multiply, go over to divide, and we will equal my answer. When we punch that into my calculator, you should get about 542 centimeters. This is the map distance we actually need to use. And so when we calculate this out, we can jump back to my lab here. And now I know where Nagata, Japan is because we have placed them all. Now I can actually draw out my radius and my circle. So what I'm going to do is I suggest take a ruler, draw it out here, draw out a point. Let's say it's about here. I don't know how far actually it is. Let's say there. That's 500, or sorry, 542 centimeters. Then take it again, draw another shape. It'll be much easier. Take a pencil, draw it out, and keep drawing my radius all the way out. I can kind of cheat now, grab a different shape. I'm going to grab a circle about that big. That looks about right. And there I will draw my circle around Nagata, meaning the earthquake could have been anywhere along this circle. It started somewhere along this circle. I will do the exact same thing for Yokohama, Hiroshima, Seoul. I'll do it for all of the data sets because when I get all my circles, I'll get another circle around Yokohama, something like this. Maybe it's a little bit smaller. Place it right there. I might have another one around a different city. Might be popping up over here, let's say. And what I will actually see is right around here, 3 points, 4 points, they all will converge around one little point. And this would be my epicenter. I did not do it to scale, I did not hand draw it, so this is not accurate, but the idea is the same. So hopefully we understand that we need to figure out magnitude, figure out my radius distance, that 5.42 centimeters, and then I can measure this on the map once I find all these places. Pretty straightforward. After that, go through some of the analysis questions. Once you finish this, please make sure to draw it, save it. If you have any questions, please do not hesitate to ask. Thank you and have a great day.